Hello students, in this video we are going to evaluate integrals using Cauchy Residue Theorem in complex analysis. This is Cauchy Residue Theorem. Integral over C f of z dz is equal to 2 pi I into summation j ranges from 1 to n residue of f of z at zj. That is, first we have to find all the residues and we have to sum all the residues. This is summing all the residues, and finally we have to multiply it by 2 pi I. But with the condition, after calculating the pole, first we have to make sure, we have to confirm whether that pole lying inside the curve or not. Let me do a problem. The first problem what we have is, we are going to evaluate the integral over c dz by 2z plus 3, where c is mod z equal to 2. Generally, the equation of a circle is modulus of z minus a equal to r, where a is the center and r is the radius. Here the given equation is modulus of z equal to 2. Modulus of z equal to 2 can be written as modulus of z minus 0 equal to 2. So with center 0, 0 means 0, 0 point, and radius 2. Radius 2 means here the length of the radius is 2. So 1, 2 means 2, 0. This side it is minus 2, 0, and this side 0, 2, and this side 0, minus 2. So like this the circle will come. Okay, it's not exact circle, but this is a circle. Okay, with center 0, 0 and the radius 2 at all the sides. So this is this curve given. This is our C. So for that C, we have to calculate integral over C dz by 2z plus 3. So the given integral, no, this is our integral. Leaving f of z, whatever we have, no, take that as f of z. F of z is equal to 1 by 2z plus 3. Not f of z here. First we have to rewrite this. Z coefficient should be 1. Then only we can calculate pole. So keep this in mind. The coefficient of z should be 1. Because in the denominator, either we can have a term like z minus a or z plus a. Okay. So first we have to make the coefficient of z as 1. So for that, what I am going to take is, I am going to take 2 outside. So it is z plus 3 by 2. Why we are getting this 2? Only 3 we have. So இல்லாத ஒரு term numerator எடுத்தீங்கன்னா அது denominator வந்துரும். So z plus 3 by 2. This integral over c. So this can be written as, this 1 by 2 I can take outside. 1 by 2 integral over c dz by z plus 3 by 2. So now this integral alone we are going to calculate using Cauchy residue theorem. So this integral only we are going to evaluate. So first we have to find the pole. How to find the pole? So leaving this f of z, first we have to write. Leaving this dz, first we have to write the term what is there, no, that as f of z. So f of z is equal to, leaving d of z, 1 by z plus 3 by 2. Now we have to find the pole. So z plus 3 by 2 equal to 0 implies z equal to minus 3 by 2. Since it is coming only once, it is a simple pole. So what kind of pole it is? It is a simple pole. So f of z is equal to 1 by z plus 3 by 2. No, in two ways we can find. I will tell you the first one. Taking this as h of z and this as k of z. What is the formula for finding the residue? Residue of f of z at the pole A is equal to h of a by k dash of a. Am I right? A here, a is equal to minus 3 by 2. So h of 3 by 2 by k dash of 3 by 2. What is k of z? This one. So when we differentiate this, k dash of z is equal to z, when we differentiate it is 1 plus 3 by 2 it is 0. So this is 1. Okay. H of z is also 1. So h of minus 3 by 2, since it is 1, it is 1. Similarly, k dash of 3 by 2. 3 by 2 is also 1. So the formula what we have is, h of 3 by 2 is 1. K dash of 3 by 2 is also 1. So it is 1. So residue of f of z is 1. Okay. So what is Cauchy residue theorem formula? 2 pi I into sum of the residues, integral over c dz by z plus 3 by 2 is equal to 2 pi I into sum of the residues. Here only one residue we have. That answer we got as 1. 1. So 2 pi I into 1. 2 pi I. Okay, before actually I forgot to tell this. After calculating the pole, first we have to make sure that pole lying inside the circle or not. What is the pole we are getting? Minus 3 by 2. Minus 3 by 2 means minus 1.5. 1.5 means minus 1.5 means the point is minus 1.5 comma 0. Minus 1.5 means 1 and 2. Here it may come minus 1.5 comma 0. ஸோ வெறும் minus 1.5 சொல்ல முடியாது. அதை பாயிண்ட்டாக கன்வெர்ட் பண்ணி அது எங்கே உள்ளே இருக்கா வெளியில் இருக்கான்னு பாருங்கள். இது இந்த சீக்குள்ளே தானே இருக்குது. பிகாஸ் 2 வரையும் நமக்கு எல்லா சைடும் இருக்கும். 1.5 டிஃபால்ட்டாக லையிங் இன்சைட் த சர்க்கிள். இன்சைட் த சர்க்கிளாக இருந்தால் தான் நம்ம ரெசிடியூ கேல்குலேட் பண்ணணும், அதுக்கப்புறம் ஆட் பண்ணணும். இஃப் இட் டஸ் நாட் லையிங் இன்சைட், அதாவது அவுட் சைடில் வந்துருச்சுன்னா நமக்கு ரெசிடியூ கேல்குலேஷன் தேவையே இல்லை. ஜஸ்ட் அதை விட்டுட்டு other residues we have to calculate. So whichever poles lying inside only we have to calculate. We have to go for the residues. Is it clear? So since it is lying inside, we have to calculate the residue. Already it is done. But before doing this, first we have to make sure that is concerned pole lying inside or outside. Okay. So inside irukanaala nama idellame same varum up to this final answer. Then here 2 pi I into 1. But this is not the final answer because the original problem we have converted as 1 by 2 into this thing. No, this alone we got as 2 pi I. So 1 by 2 into this alone we calculated as 2 pi I. So into 2 pi I. 2 we can cancel. So final answer for this evaluation is pi I. Is it clear? Okay. Now come to the next problem. So the second problem what we have is we are going to evaluate the integral dz by z squared e power z, where c is a circle with center 0 comma 0, that is center 0. Mod z equal to 1 means center 0 comma 0 and radius 1. So 1 in all the sides. So this is 1 comma 0, this is 0 comma 1, this is minus 1 comma 0 and this is 0 comma minus 1. So in this we have to calculate the residue. Only this term we can calculate the pole, not for this, no. So I can rewrite this leaving d of z, whatever term we have, no, let it be f of z. So f of z is equal to 1 by z squared e power z. For this one alone we can calculate the pole. So this one I can take to the numerator as e power minus z into z squared. So இந்த மாதிரி இருந்ததுன்னா நம்ம இதிலேருந்து போல் calculate பண்ணிடலாம். e power z denominatorல வச்சோன்னா போல் calculate பண்ண முடியாது. So we are taking that to the numerator. e power minus. Now என்ன போல் வரும்னு சொல்லுங்க. z equal to 0 is a double pole. Am I right? ஏன்னா whole squared இருக்கா? z squared 0 கொடுப்பீங்க. So z equal to 0, 0 ரெண்டு ஆன்சர் வரும். 0, 0 அப்படின்னா we can say z equal to 0 is a double pole. Double pole அப்படின்னா ரெசிடியூக்கு என்ன ஃபார்முலா? ஃபர்ஸ்ட் we have to make sure இது இந்த சர்க்கிள்குள்ளே இருக்கா வெளியில் இருக்கா. 0ன்றது சென்டர் 0, 0. ஸோ இட் இஸ் லையிங் இன்சைட் த சர்க்கிள். ஸோ அதை நம்ம மென்ஷன் பண்ணணும். திஸ் லைஸ் இன்சைட் த சர்க்கிள், ரைட். ஸோ அது உள்ளேயே இருக்குது. ஸோ நம்ம என்ன பண்ண போகிறோம்? நெக்ஸ்ட்டு ரெசிடியூ கேல்குலேஷன். ரெசிடியூ கேல்குலேஷனுக்கு என்ன ஃபார்முலா யூஸ் பண்ணுவோம்? டபுள் போல் அப்படின்னா இந்த டேர்ம் தவிர மீது என்ன இருக்கோ அதை நம்ம g of zன்னு எடுத்துப்போம், ரைட். ஸோ g of z is equal to e power minus z. டபுள் போல்னா என்ன ஃபார்முலா? m equal to 2 தானே. அப்போ m minus 1 1 of போல் என்ன எடுத்திருக்கோம்? 0 by 1 factorial. g 1 of 0 by 1 factorial. m equal to 2 here. 2 means 2 minus 1 1 of pole 0 by m minus 1 2 minus 1 factorial. Okay. So g dash of z first we have to calculate. E power minus z differentiate பண்ணீங்கன்னா e power minus z into minus 1. So minus e power minus z. இதில் g dash of நம்ம 0. So minus e power minus 0, that is minus 1. So it is minus 1. So இதில் formula apply பண்ணீங்கன்னா minus 1 by 1 factorial, which is minus 1. Okay. Now we have to substitute that. What is the formula we have? Integral over c dz by z squared e power z is equal to 2 pi I into sum of the residues. Here only one residue we have. What is that? Minus 1. So 2 pi I into minus 1, which is minus 2 pi I. Is that clear? Now come to the next problem. Evaluate integral over c 2 plus 3 sine pi z by z into z minus 1 the whole square, where c is a square. Here it is a square having the vertices 3 plus 3i. 3 plus 3i means the point 3 comma 3. 3 minus 3i means the point 3 comma minus 3. And this is the point minus 3 comma plus 3. And this is the point minus 3 comma minus 3. Is it clear? Are you clear how I am writing the points? So x coordinate comma y coordinate, real coordinate comma imaginary coordinate. So 3 comma 3, here 3 comma minus 3, minus 3 comma plus 3 and minus 3 comma minus 3. So using this curve, we are going to evaluate this. Okay. So first we have to draw the curve, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3. The first point is 3, 3. So it lies in the first quadrant 3, 3. The next point is 3, minus 3. 3, minus 3 means positive x-axis negative. So it lies in the fourth quadrant 3, minus 3. And the third point is minus 3, plus 3. Negative x positive y, so it lies in the second quadrant minus 3, plus 3. And this is minus 3, minus 3. So it is in the third coordinate minus 3 minus 3, third quadrant, right? So joining all these points, we are getting a square. First we have to find the poles. So using this we have to find the poles. So what we have in the denominator is z into z minus 1 the whole squared. Am I right? So which is equal to 0 means z equal to pole, it comes only one time, so it is a simple pole. And z minus 1 the whole squared equal to 0 means 2 times. So it is a double pole or pole of order 2. Double pole we can say, or pole of order 2. That is m equal to 2. So we have two terms 0 and 1. We will do, we have to find the residues one by one. So z equal to 0, we are going to find the residue first. So how we are going to do is, we have one formula, first result. I'll show you which result. This is the result we are going to use. Z equal to a is a simple pole, means residue of f of z at the pole a is equal to limit z tends to a into z minus a into f of z. Using this result, we are going to find the residue. So here, residue of f of z at the pole 0 is equal to limit z tends to 0, z minus 0 into f of z. Okay. So z minus 0 into f of z means, which is equal to, so limit z tends to 0, z minus 0 into f of z is 2 plus 3 sine pi z by z into z minus 2. So these two terms will get cancelled, because when we substitute limit z tends to 0, that term should not be there in the denominator. At the denominator la irundaduna neenga 0 nu kodukkumbodhu and the term 0 vairum, anything by 0 infinity. So அதை avoid பண்றதுக்கு தான் first multiply பண்ணி அதை நம்ம eliminate பண்ணிட்டு அது இல்லாத term கொண்டு வந்துட்டு அடுத்து z க்கு 0 னு கொடுக்க போறோம். So 2 plus 3 sin 0 0 by 0 minus 1, it is minus 1 the whole squared, minus 1 the whole squared is plus 1. So 2 by 1, which is equal to 2. So இது நம்மளோட first pole. அடுத்து double pole ஒன்று வச்சிருக்கோமா, z equal to 2, z equal to 1 is a double pole. Double pole means m equal to 2, right? So what is the formula? G dash of pole is 1, G dash of 1 by 1 factorial. இதுதான் நம்மளோட ரெசிடியோட ஃபார்முலா. கரெக்டா? இதான நம்ம பார்த்தோம் லாஸ்ட் வீடியோவில். ஸோ G dash of 1 by 1 factorial. First G of z என்ன அப்படின்னு பார்த்துட்டு next we have to differentiate, right? So f of z is equal to 2 plus 3 sin pi z by z into z minus 1 the whole square. நம்ம z equal to 1 என்ற போலுக்கு பார்க்கும்போது அந்த டேர்ம் விட்டுட்டு மீதி என்ன டேர்ம் வச்சுருக்கோமோ அதுதான் நம்மளோட g of z. So g of z is equal to, நம்ம அந்த ஃபேக்டர் மட்டும் விட்டுறணும், 2 plus 3 sin pi z by z. இப்போ g dash of z பார்க்கலாமா? g dash of z equal to z நியூமரேட்டர்லேயும் இருக்குது டினாமினேட்டர்லேயும் இருக்குது. அப்போ u by v மெத்தட். v squared வருமா நமக்கு இங்கே? v squared v du minus u dv. That is the formula. So which is equal to, what is my v squared? It is z squared. Z into numerator differentiate பண்ணோம்னா 2 differentiate பண்ணா 0 plus 3 into sin pi z differentiate பண்ணோம்னா cos pi z. இந்த pi z differentiate பண்ணோம்னா pi வரும் into pi. So this term is over. Minus நம்மளோட numerator அப்படியே இருக்கும் கரெக்டா? இங்க ஸ்பேஸில் நான் இங்கே கீழே எழுதுறேன் 2 plus 3 sin pi z. நம்மளோட நியூமரேட்டர் அப்படியே இருக்கும். டினாமினேட்டரை டிஃப்ரென்ஷியேட் பண்ணிங்கன்னா 1, இசட்டை டிஃப்ரென்ஷியேட் பண்ணிங்கன்னா 1. இதுக்கப்புறம் ஃபர்தராக சிம்பிளிஃபை பண்ண வேண்டாம். நம்ம 1 சப்ஸ்டியூட் பண்ணி என்ன ஆன்சர் வருதுன்னு பார்க்கலாம். சரியா? therefore g dash of 1 is equal to 1 சப்ஸ்டியூட் பண்ணுவீங்களா? z into, that is 1 into 3 cos pi into 1 cos pi into pi. Okay, minus 2 plus sin pi z. sin pi z க்கு நீங்க என்ன 1 கொடுப்பீங்களா? sin pi is 0. So 2 plus 3 into sin pi is 0 by z square, that is 1 square. Cos n pi is equal to minus 1 power n. Sin n pi is equal to 0 when n is an integer. Integer ஆயிருந்தாதான் cos pi, cos 3 pi, cos 5 pi இதெல்லாம் minus 1 வரும். cos 2 pi, cos 4 pi, cos 6 pi இதெல்லாம் plus 1 வரும். சைனில் என்ன பை வந்தாலும், sin pi-யாக இருந்தாலும் சரி, sin 2 pi or sin 3 pi, all the values are 0. Okay, so what we are getting is, this is minus 1 into pi into 3. So minus 3 pi, this is 0, so this will vanish. Minus 2 by 1 squared is 1, so by 1. So we are getting minus 3 pi by, sorry, minus 3 pi minus 2. நம்மளோட formula என்ன சொன்னோம்? g dash of 1 by 1 factorial. So therefore residue is equal to minus 3 pi minus 2 by 1 factorial 1. So it is minus 3 pi minus 2. This is the second residue. First residue is 2. Second is minus 3 pi minus 2. So finally, the integral over C, the given problem is equal to 2 pi I into summing the residues. First residue is 2. The second residue we got as minus 3 pi minus 2. So plus minus 3 pi minus 2, which is equal to 2 pi I into plus 2 minus 3 pi minus 2. These two will get cancelled. So 2 pi I into minus 3 pi plus into minus minus 2 into 3 6 pi into pi pi squared into I. So this is the final answer for evaluating the given problem. Is it clear? Thank you.